Artificial intelligence, an attempted definition. Artificial intelligence, AI, may be defined as the branch of computer science that is concerned with the automation of intelligent behavior. This definition is particularly appropriate to this course in that it emphasizes our conviction that AI is a part of computer science and, as such, must be based on sound theoretical and applied principles of that field. These principles include the data structures used in a knowledge representation, the algorithms needed to apply that knowledge, and the languages and programming techniques used in their implementation. However, this definition suffers from the fact that intelligence itself is not very well defined or understood. Although most of us are certain that we know intelligent behavior when we see it, it is doubtful that anyone could come close to defining intelligence in a way that would be specific enough to help in the evaluation of a supposedly intelligent computer program, while still capturing the vitality and complexity of the human mind. As a result of the daunting task of building a general intelligence, AI researchers often assume the roles of engineers fashioning particular intelligent artifacts. These often come in the form of diagnostic, prognostic, or visualization tools that enable their human users to perform complex tasks. Examples of these tools include hidden Markov models for language understanding, automated reasoning systems for proving new theorems in mathematics, dynamic Bayesian networks for tracking signals across cortical networks, and visualization of patterns of gene expression data, as seen later. The problem of defining the full field of artificial intelligence becomes one of defining intelligence itself. Is intelligence a single faculty? Or is it just a name for a collection of distinct and unrelated abilities? To what extent is intelligence learned as opposed to having a priori existence? Exactly what does happen when learning occurs? What is creativity? What is intuition? Can intelligence be inferred from observable behavior? Or does it require evidence of a particular internal mechanism? How is knowledge represented in the nerve tissue of a living being? And what lessons does this have for the design of intelligent machines? What is self-awareness? What role does it play in intelligence? Furthermore, is it necessary to pattern an intelligent computer program after what is known about human intelligence? Or is a strict engineering approach to the problem sufficient? Is it even possible to achieve intelligence on a computer? Or does an intelligent entity require the richness of sensation and experience that might be found only in a biological existence? These are unanswered questions, and all of them have helped to shape the problems and solution methodologies that constitute the core of modern AI. In fact, part of the appeal of artificial intelligence is that it offers a unique and powerful tool for exploring exactly these questions. AI offers a medium and a testbed for theories of intelligence. Such theories may be stated in the language of computer programs and consequently tested and verified through the execution of these programs on an actual computer. For these reasons, our initial definition of artificial intelligence falls short of ambiguously defining the field. If anything, it has only led to further questions and the paradoxical notion of a field of study whose major goals include its own definition. But this difficulty in arriving at a precise definition of AI is entirely appropriate. Artificial intelligence is still a young discipline, and its structure, concerns, and methods are less clearly defined than those of a more mature science, such as physics. Artificial intelligence has always been more concerned with expanding the capabilities of computer science than with defining its limits. Keeping this exploration grounded in sound theoretical principles is one of the challenges facing AI researchers in general, and this course in particular. Because of its scope and ambition, artificial intelligence defies a simple definition. For the time being, we will simply define it as the collection of problems and methodologies studied by artificial intelligence researchers. This definition may seem silly and meaningless, but it makes an important point. Artificial intelligence, like every science, is a human endeavor, and perhaps is best understood in that context. There are reasons that any science, AI included, concerns itself with a certain set of problems and develops a particular body of techniques for approaching these problems. In Lecture 1, A Short History of Artificial Intelligence and the People and Assumptions that have shaped it, we'll explain why certain sets of questions have come to dominate the field and why the methods discussed in this course have been taken for their solution.